Hello guys, my name is Lazar and today we'll be doing another LeetCode problem. This problem is called Decode Ways. A message containing letters from A to Z can be encoded into numbers using the following mapping. A maps to 1, B to 2, and so on and so forth, up to Z where that maps to the number 26. And keep in mind this number is a string. To decode an encoded message, all the digits must be grouped, then mapped back into letters using the reverse of the mapping above. So if A maps to 1, then we see the number 1 that maps to A. Here's a little example. AAJF can be mapped into the grouping 1, 1, 10, 6. And then KJF can be mapped to the grouping 11, 10, 6. And if we see the numbers 11, 10, 6, we can decode this into KJF. So it really goes both ways. Now something else they want us to keep in mind is that the grouping 11106 is invalid because 06 cannot be mapped into F since 6 is different from 06. So we can't really have any leading zeros. For example, we can't have 01 or 001. That would make it invalid and it would not map to A. The only thing that maps to A is exactly 1, not 01 or 001. Which is why here they didn't include a potential grouping of 11106. Also, something else, keep in mind that these two numbers are exactly the same, but they do represent different letters. And that's kind of what they want us to solve. So given a string S containing only digits, return the number of ways to decode it. This is exactly what the question is asking us. If we're given these digits, it could be decoded in two ways. It could be decoded into AAJF or into KJF. It all depends on how we group these numbers. They also want us to keep in mind that the test cases are generated so that the answer fits in a 32-bit integer, which this is basically telling us not to worry about any overflow, and we don't have to do any modulo operation on the final answer. Instead, we can just return the output as is. So let's look at the first example. The first one we have 1, 2. This could be decoded into AB. 1 goes to A, 2 goes to B. Or it could be grouped together into the number 12, and that could be decoded to the letter L. Therefore, the answer for this is just 2. Keep in mind, this is something really important here, that the number of single digits we have is only 1. Because if we want to put this out as a answer, if we were to group it just by single digits, we can only output 1, which is that AB. And if we were to take now the doubles, uh, in this case which is 12, there's only one double, and it's 12. So the number of singles plus the number of doubles will give us 2. So 1 plus 1 will give us 2. This becomes a little bit more apparent in example 2, where we have S is equal to 226, and the output is 3. That's why, which is because 226 can be decoded as 2 and 26, which is BZ, or 22 and 6, which is ZF, or 226 BBF. Now if you guys notice, this follows the exact same pattern as example 1, where the answer is the number of singles, which is this 2 and then the 6, or all of them as singles, which is 226, plus the number of doubles, which is the 26 and then the 22. So the number of singles is actually 2, because we can either have all of them as singles, or we can either have the 2 or 6. So that's 2. And then the number of doubles is 1, because we can either have the Z or the V, the 26 or the 22. Therefore, 2 plus 1 will equal 3, and that's our output. Then example 3 just follows this note right here that we need to keep in mind, that if it's followed by 6, it cannot be mapped to a single number. It cannot be mapped to F. Therefore, the answer to this is just 0. So let's go and build off the intuition that we mentioned, where for every single number, let's call it f of x, where x is the current number we're considering or considered taking, it's going to be equal to the number of singles plus the number of doubles. Now something I want to keep in mind for a very simple input, let's say that 1 and 2, initially singles is just 1 because we can have 1 and 2 which will map to A and B. And the number of doubles will also be 1 because we can have 12 which would map to L. So initially, if our input size is just 2, the number of singles we can create is 1, and the number of doubles we can create is also 1. But this changes a little bit if our input is that 0, 6. If the first digit is a 0, then singles should be changed from 1 to 0. Now the reason we can't make any singles out of this is because even if we break it up and we have that 0, 6, 0 does not map to anything, so we can't use this. And we can also just group it together to the 0 and 6 because that also doesn't map to anything. So what we need to do if we see a scenario like this is change our singles to 0. But we do want to leave our doubles as 1. The reason for that will become obvious with the next example we show. Now let's say our input is something like this second example right here, the 226. Since we have already taken the care of the first two, we want to look at index 2. And now we want to look backwards. We first want to check if the previous number, so there's 2 right here, we want to check if that's a 0. The reason we want to do this is because if that is a 0, then we need to reset singles to 0. Because remember, this 0 does not only have to appear in the beginning, it can really appear anywhere in our string. And anytime we see a 0, we're basically doing a reset. Because the number of singles we can use once we see zeros gets reset. Because we cannot take anything before that unless we're pairing it with a double. If here we pair a double, we can have, well, it doesn't even work because we have a 0 in the beginning. But if we didn't have that 0, for example, let's say we have something like this. This would work because we can take 6, 2, 10, and then 7. But if we're only keeping track of zeros once we do see but if we're only keeping track of singles, once we do see a 0, the number of singles we can see does need to be reset. In this case, the 2 is not a 0, so we're okay. We don't have to do anything to our singles count. But something that is going to change, in this case, the 2 is not a 0. In this case, the 2 is not a 0, so we don't have to reset singles. The singles is still going to change. The reason it's going to change is because the previous two numbers, once we group them together, it's 22. And 22 is greater than or equal to, and less than or equal to 26. So what this tells us is that 22 is within our mapping. If it's within our mapping, then we can construct a double out of this 22. So now single needs to be updated, and it needs to be changed from 1 plus the number of doubles we can create, which in this case would be 2. Now, if we look at this formula, keep in mind how single changes for every character we're looking at. So single is really our f of x. Another way of writing this is maybe f of x is equal to f of x minus 1 plus f of x minus 2 plus f of x minus 1. Now this second part right here needs to be within, needs to be greater than or equal to 1 or less than or equal to 26. And this first part needs to be greater than, let me change it around, it needs to be greater than or equal to 1, but then less than or equal to 9. So this is the requirements for singles and doubles. So I'll leave that up there. So now so now single gets updated to 2. And what does doubles change to? Well, doubles change to the original singles. So originally single was just 1. So that's what doubles is going to change to. So doubles stays 1. And that makes sense because here we can only have one double, which is just 22. But we're not done. Since once we were looking at 6, we looked at the numbers before it. So yes, one number before it and then the two numbers before it. We want to look outside of the string as well. So we want to go just one outside of the range and then look before it. So we can take into account this 6. Now this 6, it's not a 0, so singles can stay 2. Then the number of doubles, can it be increased or can it be added to singles? The answer is yes, because 26, the last two numbers is 26, and that is valid within our range. So now, I forgot an S here. So now singles be equal to 2 plus double, which is 1. Therefore single is now 3. And doubles is going to change to 2, which is the previous singles before it got updated. So why is doubles now 2? Well, it's because we can have 22 or we can have 26. And this is really how we solve this problem, by just keeping track of the singles and the doubles that we can create from this string. So hopefully this makes sense. If it doesn't make total sense, that's totally understandable. We are using dynamic programming because as we go through this string, we're solving a smaller set, a smaller sub problem, which was in the beginning just a 22. And then we're taking into account this larger problem, which is the 226, by using information that we gained from the smaller subproblem. The dynamic programming is pretty difficult to understand, so if you guys didn't fully follow this, then work through a couple of examples and see how keeping track of the singles and doubles, how important that is. So now that we can get into the programming. So first I'm going to start off with our singles and the doubles variable, which they're both going to be set to 1. And if s0 is equal to 0, then we want to reset our singles. Other than that, we just want to do a for loop starting at index 2 all the way to the length of s plus 1. Now let's store the last singles in a temporary variable, and if the previous number was a 0, then we want to reset our singles and set it equal to 0. Another if we want to do is if the integer, we convert it to an integer of the number 2 indices before plus the number of 1 index before. So this is taking, this right here is taking two numbers, so it will take the 12 or it will take the 22. If this is between, if this is between 10 and 26, so if it's greater than 9 and less than 27, then we know that we have a double and we want to add this double to our singles. And then finally, we want to set our doubles equal to the previous singles. And then all we have to do is just return the number of singles. So now let's run this code, see if it works, see if I made any mistakes. Doesn't. Let's try some more test cases. And now we can submit. And it gets accepted. Perfect. So hopefully you guys enjoyed this video. If you did, please leave a like and consider subscribing. But other than that, hopefully this video did help you guys. I know it's pretty confusing to understand it because this is dynamic programming and we're doing a very optimized approach of dynamic programming. Is because we're not using a DP table where it will make our space complexity of n. Instead, we're using variables which makes our space complexity O of 1, constant space complexity. And our time complexity is still O of n because we have to iterate over the length of this string. So this is a optimized solution, which of course makes it a little bit more complex. It might be a little bit more confusing to understand. So if that's the case, then make sure you guys really work on it to understand why it works and what's the importance of keeping track of the singles and doubles. But other than that, thank you guys for watching.